If we were to rewrite this equation so it's a little bit cleaner, we'll find that we actually have a lot of information about the variables inside it. And that rewritten equation would be xb minus x of a times xb dot minus xa dot plus y of b minus y of a times y of b dot minus y of a dot equals 0. We just found this, and that is r squared minus y of a squared. We found x of a dot, which is y of a times y dot of a over x of a. We also just inferred from the problem that's given, found that y of b is equal to negative r, and we found that y dot of b is 0. So let's now fill in this equation for the parts that we don't know. And that's x of b dot minus x of a plus minus r minus y of a minus y of a dot equals 0. What is left? A lot of position values as well as y dot. So we need to find x of b as well as x of a dot, y of a, another y of a. We have the y of a dot here, another y of a, x of a. So position and y of a dot. Let's see how we can get those. The x of a and y of a is fairly straightforward from the problem given, and that is x of a equals negative r sine of 60, just the radius in that angle. Y of a is just the same with a cosine of 60. X of b, that is given as 2 meters per second. But what about the position of x of b at 60 degrees? Well, we also have an equation for that too. Let's look at the version of this equation before we took the derivative of it. That is x of b minus x of a squared plus y of b minus y of a squared equals 2r squared. We just found that this is sine of 60, and this is negative r cosine of 60, and we inferred earlier that this is negative r. And when it's simplified, we'll have all of the values work out because these r's end up canceling. And they're all squared, so it works out great. And then you get that x of b is equal to 1.070r. This r comes from the fact that these are squared and they get a polynomial. And we can plug this x of b up here. And now we can solve for x dot of a. No, we're solving for y dot of a. And when you solve for that, you get y dot of a equals to negative 2.39 meters per second. And this is where all the r's end up canceling out. Y dot of a. Very important that we found that. Now let's look for x dot of a. And that is going to be a little bit easier because the equation from earlier is a little bit simpler. We have x of a times x of a dot plus y of a times y of a dot equals 0. We just found a lot of that information, so we can solve directly for x of a dot, where we have y of a, negative y of a times negative y of a dot over x of a, and negative r cosine of 60 times negative 2.39 that we just found here, all over negative r sine of 60. And that value for x dot of a is equal to 1.392 meters per second. Now we have the two components of x dot of a and y dot of a. Because that is a right angle, we can use Pythagorean's theorem and put x dot of a squared plus y dot of a squared and take the square root of that. And you find that v of a is equal to 2.76 meters per second. It is a lot of dancing around in equations. I suggest you just be okay with using up a lot of paper. You can reference back to equations, but I find that rewriting them really helps me understand what's going on, especially for on an exam. It'll help you keep track of everything a little bit better, because you have two triangles, the position equation of those triangles, the derivation of those triangles, and then assumptions that you make at the beginning and the given values.